Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a nice and easy problem with complex numbers. Now we have two constants A and B, and we have this equation, and we're supposed to solve for A and B because those are the only variables, right? And I'll show you two methods for this problem. One method is something you should probably not use for this problem, and I'll explain why. And one thing that I like about this problem is I think it's a good problem, even though it's easy for beginners at least, right? I know not everybody is like advanced, not everybody has advanced knowledge in complex numbers. I don't have either. Anyways, so let's go ahead and see how this plays out. First method, I'm going to go ahead and make a common denominator because why not, right? When you see a problem like this, and this kind of goes back to what's it called, partial fractions, something we use with rational equations, rational expressions, with calculus. Sometimes you need to integrate something complicated like 1 over x cubed plus 1. You factor it and then you kind of split it up so that you can integrate each one easily, right? So that's a really good technique that you can use, and there are some shortcuts, and I've done a lot of videos on that one. You can go ahead and check them out. And by the way, I also have another channel, maybe that's where you came from, called Cyber Math. That's cyber with an S. Okay, great. Now let's go ahead and see how we can solve this problem using a method that you should probably not be using. But why am I showing it? Just for fun, okay? Sometimes you learn from the wrong methods too. Not wrong, it's definitely gonna work, but you'll see what I'm talking about in a little bit. So with partial fractions, we make a common denominator, so why not do the same thing here? So that means we're gonna multiply a by 7 plus 4i, and then b by 8 plus I, and of course the denominator is just gonna be made up of the product of these two complex numbers, right? And on the right hand side, everything stays the same for now at least, right? So let's go ahead and keep it that way. Now we're going to go ahead and distribute, and that'll give us the real part as 7a plus 8b, and then the imaginary part is just going to be 4a plus b, and that is the coefficient of I over the same thing. Should I distribute or not distribute, right? That's the question. Now, in this case, I think distribution would probably work well because you have to simplify this at the end, right? So here's what we need to look for. We're going to distribute this because we're kind of multiplying three complex numbers. You can't do all three at the same time, can you? So let's go ahead and distribute. So this is going to turn into the following: 7a plus 8b plus 4a plus b as the coefficient of I. That is multiplied by 65. And then that is equal to 8 plus I, 7 plus 4I, and 37 plus 14I. Beautiful, right? Not really. But anyways, distributing the 65 over, we're going to get something like this. And we can leave it like that for now. Or just totally forget about 65. You don't really care. Let's go ahead and distribute these first. This should give me 8 times 7 is 56. Let's do the math. 8 times 4 is that's 32i, and then 7i, and then minus 4. Oh, one thing I forgot to say, I squared is equal to -1. I forgot to say the most important thing, right? So because I is the square root of -1. And check out the lecture videos if you're new to complex numbers. So that's how I got the -4 from 4i squared, because I squared is -1, okay? This is 52 plus 39i. And now that needs to be multiplied by, uh-oh, that's not good. Big numbers, large numbers, right? But maybe we can go ahead and factor something out of this. Not sure about that. Maybe we can divide the right-hand side by 65, but only after multiplying and simplifying, right? That could work. If we're expecting to see good answers, obviously, like for A and B. I'm hoping that I came up with good values because I made up this problem. Did I say that? I came up with this problem. You probably won't see this problem in textbooks or any other channel because these are homemade problems. Obviously, someone else can make the same problem. And guess what? Some people just copy my problems and they don't even refer to. Anyways, that's a different story. Let's continue with this. So we're going to multiply 52 times, and no, I haven't memorized the value. So I'm going to go ahead and multiply. This is 364. This is 156. 4291. 1924, like sounds like a year, right? So that's one. And then what else do I need? Ooh, wow, this is really super annoying. I should use a calculator, right? Okay, fine. 208, this is 50. This is good arithmetic exercise, right? That's 728. Wow, that's amazing. You know what I just realized? That it's one less than 729, which you should know as 9 cubed, right? So maybe that's how it's factorable. Who knows? So that's another one that I needed. And then now I do need 39 times 37. And are these divisible by 65 by any chance? I don't know. Let's see. That's 273. 117. Okay, 4. Come on. 1443. Okay. And then finally, I got to do 39 and 14. And then I do some subtractions. Oh my God, this is taking forever. Okay. 156, 39, 5. Okay, great. Now, we have everything we need. This is 1924. Oh, come on. Notability. And then I have this. That's going to be subtracted minus 546 because of I squared is negative 1, right? Let's move this over here like this. All right. And then I do need let's see. I do need 52 times 14 plus 39 times 37. So I need this plus this. Okay. Right? No, wait a minute. I messed up. No, I do need the i's. Never mind. No. I do need 52 times 14. No, not this one. I need this one and this one. Right? Yep. And they'll be added because they both have I in them. So if you add 1443 and 728, you get 1, 6, 7, and 21. Great. That gives me 2171I. So this is our number on the right-hand side, and that's equal to this. So, oh, I got to subtract this. Yeah, of course. What are you thinking, right? Okay, 546, a lot of arithmetic here. That's an 8, that's a 7, that's a 3, and 1. I hope this number is divisible. I lost patience, guys. This is too much work. For someone lazy like me, this is way too much work. But anyways, at the end, I'm hoping that this number is divisible by 65 so that you can do the math, okay? But as you can see, this method is not good at all. I don't think you're gonna like it. And this is what you should not be doing. When you see a problem like this is a good example. You don't always, you see, problem with some of the solutions that you see in textbooks or on YouTube is that they always show you the correct solution, right? The good one, the best one. But that doesn't really teach you anything. Like, how do you know which method is better, right? Through practice, of course. But let me tell you something. Whenever you get a complex number, when you see a complex number in the denominator, eliminate it. Make it real by using the complex conjugate. What do I mean by that? So you can go ahead and multiply this by 8 minus I, and 8 minus I here. And then this one you can multiply by 7 minus 4I, and 7 minus 4I, right? So in other words, if you have A plus BI, the complex conjugate is A minus BI, and their product is real, their sum is real, it's all real, guys. This turns into sum of two squares from difference of two squares. Again, I go over these in lecture videos, but take a look at how smooth this is. Now you multiply A by that and B by that, okay? And in the denominator, wait a minute, do we have a common denominator? Yes, we do, because you know why? This is 64 plus 1, which is 65. This is 49 plus 16, again 65. That's how I came up with this problem. I needed two sets of squares that add up to 65, and it just worked, okay? Yeah, I just used a little bit of AI here. to come up with the numbers because, again, I'm lazy, right? 65 cancels out, ta-da-da-da, you get the following. 8a plus 7b, and then minus, or plus, minus a minus 4b, okay, I guess I can write it like this, is equal to 37 plus 14i. And from here we get the following. This is equal to 37, so we get a system of equations which should be fairly easy to solve. And you know what? We can just negate this because I don't like the negativity on the left-hand side. 2 negative. Let's just make 1 negative, okay? Now, how would you solve a system like this? Probably you would multiply the second equation by -8, right? Let's do that. And that gives us the new system, -8a minus 32b is equal to, please work, I need this to work, 112, but that's negative, right? And then I have 8a plus 7b is equal to 37. I'm hoping that this is going to work. Cross our fingers. These two cancel out, and we end up with -25b. And this will give me, let's see, 75, but negative. Yay! B is equal to +3. And plug it into one of these equations, probably the second one. A plus 12 is -14. A is equal to -26. Did I get that right? Let me check with the first equation. 8a plus 7b, which is 21, is 37. 8a is what? If b is equal to 3, a cannot be -26. Okay, something wrong with this. Oh, please do work. 8a plus 7b is 37. 8a is 16. Okay, great. So this is wrong. A is equal to 2. I probably messed up somewhere because I knew that I came up with good numbers, right? Like, hopefully. So those are the values, and this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and don't forget to check out Cyber Math, the Shorts channel, and aplusbi, and bye-bye.